Find the vector equation of a line passing through A and B. So we have a line. So this is point A and this is point B. So the vector equation of the line L is going to be, this is capital letter L. So it is going to be R equals to OA, position vector of the first point, plus lambda, direction vector, AB, which is also universal position vector. That's what this denotes. So A, we already know what A is. So this is 5j plus 5k, and we have to find AB, the direction vector. So let's find AB first. AB equals to OB minus OA. So OB is 3i plus, so 3, 2, minus 1. This is OB. Minus OA is, there is no I, so I is going to be 0. 5j is 5. 5k is 5. So if we subtract this, this would be 3. This would be minus 3. This would be minus 6. So the direction vector is going to be, once we take the scalar common, so if we can take 3 common, it would be 1, minus 1, and this would be minus 2. So the direction vector is going to be what we have besides the scalar quantity 3. So therefore, the vector equation of the line is going to be OA. So OA is going to be 0, 5j, 5k, plus lambda, direction vector is 1, minus 1, minus 2. Always remember, you have to take the length common, and whatever is left over, that is the direction vector. Question number B. So it is given that C lies on the line and it is perpendicular. So it's the same question. So we have the line L, and there's a point C, which is the position vector is perpendicular. So remember, by the universal position vector rule, we can write OC is the same as the line L in form of ijk. So that means 0 plus lambda, 5 minus lambda, 5 minus lambda, and 5 minus 2 lambda. 5 minus 2 lambda. So this is this line L written in the ijk format. So it is an arbitrary position vector for any point that is unknown. So we can write OC is like this. And for finding that this is 90 degree, we can use the dot product rule, where the dot product is 0. So for the other direction vector of L, we know it is this one. 1 minus 1 minus 2. This is the direction vector, remember, when you take the constant common. So by the rule of perpendicular line, so dot product is 0. So OC dot direction vector is 0. So 0 plus lambda is lambda. 5 minus lambda, 5 minus 2 lambda dot 1 minus 1 minus 2 equals to 0. So lambda into 1 is lambda, plus minus 1 into 5 is minus 5, minus 1 into minus lambda is plus lambda, plus minus 2 into 5 is minus 10, minus 2 into minus 2 is plus 4 lambda equals to 0. Lambda plus 4 lambda is 6 lambda. Minus 5 minus 10 is minus 15. If you take it to the other side, this is going to be plus 15. Therefore, lambda equals to 15 by 6. 3 5s are 15, 3 2s are 6, so it is going to be 5 by 2. Now we can find the coordinates of C by putting the values of lambda. So 5 by 2, lambda is 5 by 2, then 5 minus 5 by 2, 5 by 2 means 2.5, 5 minus 2.5 is 2.5, meaning again 5 by 2, and 5 minus 2 into 2.5, 2 into 2.5 is 5, 5 minus 5 is 0. So we have to find the position vector of C. So it is going to be 5 by 2i plus 5 by 2j plus 0. Next question is, the point OBA together with the point D lie on the vertices of a parallelogram. That means we can write this. Question number C. So OBAD. So OBAD. The lettering is very, very important. We have to follow the order they're writing it here. So we know what B is. So B is 3, 2 minus 1. A is 0, 5, 5. O is 0, 0, 0. So we have to find the coordinates of D, x, y, z. It's the same rule. We use the midpoint rule. Remember, in a parallelogram, the midpoint of the diagonals are equal. So let's find the midpoint of BD. So midpoint of BD equals to 3 plus x by 2, 2 plus y by 2, minus 1 plus z by 2. That's it. This is the midpoint of BD. Now, midpoint of OA. So, midpoint of OA is going to be, since we're finding the coordinates, we don't have to give the vector sign. So, 0 plus 0 by 2, 0 by 2 is 0. 3 plus 0 by 2 is basically going to be 3 by 2 and 5 by 2. So 0, 3 by 2 and 5 by 2. And they're going to be equal because they are the same midpoint. So 3 plus x by 2 equals to 0. Therefore x equals to minus 3. And 2 plus y by 2 equals to 3 by 2. Therefore 2 cancels. So y equals to 3 minus 2 is 1. And finally, minus 1 plus z by 2 equals to, this is going to be 5 by 2. If you multiply by 2, 2 cancels. Z equals to 6. So D is going to have the coordinates. X is minus 3, Y is 1, Z is 6. And OD is going to have the position vector minus 3I plus J plus 6K. Now, I think this should be 5. So this should be 5. So there is a mistake over here. It should be 5 by 2 in the printing. So if this is 5 by 2, this is 5 by 2. So this should be 5 by 2. So y should be equals to 3. Okay, now it's fine. Y should be equals to 3. Minus 3, 3. This should be 3j. The final question, we have to find the area of the parallelogram OBAD. That means if we find the area of OBA and multiply by 2, that will be the area of the parallelogram. So let's find the area of OBA. It's a good idea to follow the story, how it is going along. So what we can do here is we can write that first we had L. L was the line and it passes through the point A and B. So if this is B and this is A, so this is like A and B. I'm just following this diagram. It'll be more convenient. And after that, we prove that OC is a point where it is perpendicular to the line L. So OC. Okay, so this is 90 degree. So to find the area of triangle OAB, we can use this triangle half into base into height. Height is OC and base is AB. So OC is modulus of OC. So this is OC, 5 by 2I. So that would be 5 by 2 whole squared plus 5 by 2 whole squared plus coefficient of k is 0. So 0 squared. So the length of OC is going to be 25 by 4 plus 25 by 4. So this would be 50 by 4. 50 by 4. So this would be square root of 25 by 2. So this is the length of OC. Now let's find the length of AB. We already know what the vector AB is. We found that before. Okay, this is AB. In this, since we want to find the length, we need the entire vector, not just the direction vector. So 3 minus 6. So 3 square minus 3 square minus 6 square. This is going to be 9 plus 9 plus 36. So 18 plus 36 is going to be 9 plus 9 is 18 plus 36. This is going to be 54. This is going to be square root of 54. So the area of the parallelogram is going to be area of this triangle half into base, which is square root of 54, into height, which is square root of 25 by 2. So this entire area, which is area of half the parallelogram, into 2, because there are two triangles which are equal. So it's going to be this into 2. So this 2 and the half cancels off. So it would be square root of 54 into square root of 25 by 2. So let's find square root of 25 divided by 2 multiplied by square root of 54, and this is going to be 25.98. 25.98.